Students, we are given this question. We are expected to simplify negative root 3 positive 3i. The entire quantity is raised to the power 31. Foremost, let me take this to be z. Let z be equal to negative root 3 positive 3i. Now, any complex number can be written as, we know that any z can be written as r times cos theta positive I times sine theta. Okay, so because of this, I can now rewrite negative root of 3 positive 3 times I as r of cos theta positive I times sine theta. Now my r is going to be root of squaring negative root 3 and followed by 3 square. This is going to give me negative root 3 squared is going to be 3, positive 3 squared is going to be 9. This is going to be equal to root of 12, which can be rewritten as 4 times 3, which is going to be 2 times root 3. So therefore my r is going to be 2 times root 3. Okay. Now, having obtained the r, we need to obtain alpha. So alpha is tan inverse of y divided by x, which is equal to tan inverse of, my y is 3, my x is negative root 3. So we need to have a modulus sign, and that would give us tan inverse of 3 divided by root 3, which is equal to tan inverse of, I am going to write 3 as root of 3 times root of 3. I got a root 3 in the denominator. So the root 3 gets cancelled, so giving me alpha to be equal to tan inverse of root of 3. Now tan inverse of root of 3, we know it is going to be pi over 3. So alpha is equal to pi over 3. But this is not theta. But negative root 3 positive 3i is in quadrant 2. So this means my theta is pi minus alpha, which is pi minus pi over 3, which is 3 pi minus pi divided by 3, which is going to be 2 pi over 3. So this is my theta. Having got my theta, I can now rewrite the complex number. Therefore, negative root 3 positive I times 3 is equal to, my r is 2 times root 3 times cos of my theta is 2 pi divided by 3 positive I times sine 2 pi divided by 3. This is what I have got. We are expected to find the quantity raised to the power 31. So raising both sides to the power of 31, this is going to be raised to the power 31, and this is going to be raised to the power 31. This is equal to 2 times root of 3 raised to the power 31 times cos. By de Moivre's theorem, this is going to be 62 pi divided by 3 positive I times sine 62 pi divided by 3. Now I need to simplify this quantity. So to simplify this quantity, let me show it here. So this is going to be equal to 2 times root of 3 raised to the power 31 times cos of 62 pi divided by 3 positive I times sine of 62 pi divided by 3. This is what I have got. Now what I'm going to do is I'm going to be rewriting this as 2 times root of 3 raised to the power 31 times cos of 20 pi positive 2 over 3 times pi. Okay, 3 times 20 pi would give me 60 pi, added with 2 pi would give me 62 pi positive I times sine of 20 pi positive 2 pi divided by 3. I'm writing as a even quantity because it's easy to simplify. So because this is eventually going to be equal to cos of 2 pi over 3 by the trigonometric formula positive I times sine of 2 pi over 3. Of course, I've got 2 times root of 3 raised to the power 31. So this is going to be 2 times root 3 raised to the power 31 times. Now this can be rewritten as cos of pi minus pi over 3. So that will give us 2 pi over 3 positive I times sine of pi minus pi over 3. Okay, so this is going to be giving me negative cos of pi over 3 by using the trigonometric formula. Positive I times sine pi over 3 is equal to 2 times root 3 raised to the power 31. Now cos pi over 3 is nothing but cos 60. Cos 60 is 1 over 2. So that's going to be 2 times root of 3 raised to the power 31 times negative 1 over 2 positive. This is going to be sine 60. Sine 60 is root 3 over 2. So this is equal to 2 times root of 3 raised to the power 31 times. Taking the LCM as 2, I would get negative 1 positive I times root 3. So this is what I get. So you can either stop here or stop here.